Hey guys, happy Thursday. I think it might be Friday. Thursday, I think. Um, and we're going to talk about adding and subtracting today. So please find page 6 in your notes packets. Pause me if you need to. Okay. So do you remember way back in elementary school, you guys learned about adding and subtracting fractions? Something real simple like this. 1/5 plus 3/5. We know that we need a least common denominator. We need to have the same denominator. They're already given to us. If I have 5 pieces of something, Matt takes a piece and John takes 3 pieces. How many pieces did they have take all together, right? So it's still out of the 5 pieces, right? It's part out of whole. And we're going to do 1 plus 3. We're adding our numerators. 1 plus 3 is 4. Simple as that. I bet you didn't know we could do the same thing with polynomials. If we have a common denominator, all we have to do is add the numerators. You'll remember from the last unit that we have to do is combine like terms. So I have 3x plus 5x is 8x, and I have 7 plus a negative 12, which is negative 5. And that's still over 10. Our denominator always stays the same. Even when we're subtracting, it's still the same idea. We're keeping our denominators the same, part out of whole minus the part out of whole. But we do have to be careful when we're subtracting to make sure that we're subtracting everything in that second number. So if I'm doing x minus 4x, I'm going to get negative 3x. But I have to remember that I have a negative 1 minus 11. It's not negative 1 plus 11, it's negative 1 minus 11. And negative 1 minus 11 is, you know, negative 12. It is tempting to try to simplify things like this. I'm going to rewrite it because that's going to bother my brain. Our answer is negative 3x minus 12 over x to the third minus 6. It is tempting to want to cross out the x values, or you see 3, 6, and 12, and you think, oh, maybe I can simplify. We can't. We need to have multiplication going on instead of adding and subtracting. But there you go. There's your answer. So not so bad, right? When we have common denominators, you just add the tops and keep the bottom the same. What gets a little trickier is when we have unlike denominators. So again, back to elementary and middle school, we can take a look at our 2/3 plus 1/4. I have to look for something called my least common denominator. LCD, denominator. So I'm looking at the multiples of 3 and 4. Sorry, I missed 3 and 4. So the least common denominator, or the least common multiple of 3 and 4 is 12. So I want to make my 2/3 into something out of 12, and I want to make my 1/4 into something out of 12. So I'm gonna leave some room for myself to show all of the things that I need to show. So I decided 12, right? So something out of 12 plus something out of 12. 3 times what is going to get me 12? Well, 3 times 4 is 12. But what I do to the bottom, I have to also do to the top. So we're going to multiply by 4. 2 times 4 is 8. Then I'm going to take my other fraction. I have 1/4. 4 times what is going to get me 12? Well, 4 times 3 is 12. So I'll do the same thing to the numerator. 1 times 3 is 3. Now I have two fractions with like denominators, and I can just add them. So I have 8 plus 3 is 11 out of 12. Okay, we're going to take it up a notch now. So far, we have simply added like terms with common denominators. Then we took a look at having to change our denominator. What if I told you we can do the same thing with variables? Same concept. I want to have a common denominator. So I have a b squared and a squared. So what I want to look for when I have a fraction like with these kinds of denominators is still look for that LCD. Something I can use, and I have to remember I'm multiplying. I'm not looking for a GCF. My GCF would just be A. But I'm not trying to take things out. I want to multiply to get things to be the same. So I'm looking for a least common multiple. In doing that, I want to look for each variable with the highest number of exponents to figure out um, the LCM. So I have A and I have A squared in each of those terms. So A squared is going to be part of my denominator. And then that first term also has B squared. So that second term also needs to have a B squared. The LCD, the least common denominator, for these two terms is A squared, B squared. I'm looking for the multiple, the common multiple of each of those terms. Okay, so what I have to look for then is how I'm going to multiply each of those to get the LCM. When I had just regular numbers, I knew, oh, 3 times 4 is 12. Done. 4 times 3 is 12. Good. AB squared times what? Hang on. Here we go. AB squared times what is going to get me A squared B squared? What am I missing? I think I just am missing an A. So I know I'm going to have to multiply by A. The second term has A squared, just A squared. It doesn't have a B at all. So I need to make sure I'm multiplying by that B squared. So I have it included in my denominator. So let's see. I have 1 over AB squared, my original fraction, and I decided I have to multiply by A to get a common denominator. But remember, I cannot just multiply by the denominator. I have to multiply both the numerator and the denominator um, every time. I think I wrote it that way as a fraction. If it helps your brain to just do times A, you're welcome to do that as well. But I think I'm going to start writing it like that, A over A. Then I have my original 3 over A squared, and I decided I needed to multiply by B squared to get a common denominator. Let's see if this works out. Let's see. My numerators, I have 1 times A, good. A, B squared times A. A times A is A squared, and I also have that B squared. Okay, good. 3 times B squared is 3B squared, and then my denominator, A squared times B squared. Perfect. Now, after doing all of that work, I have a common denominator. They both have the same denominator, and that's what I was looking for. I'm ready to add now. A plus 3B squared is in the numerator. I cannot combine A and B to one term, and my denominator is now A squared B squared. Ta-da! we're just finding a common denominator and then adding like normal. Sometimes, like this last one, which I don't really have room for, so I think I'm gonna find another. Here we go. You should still have, well, if you don't have room, you could use scrap paper. This is that third example, 2 over x minus 3 over x plus 2. Sometimes it's as easy as um, multiplying by the opposite thing. So I can't just add a 2 to that first expression. Unfortunately, I can't just like add it on there. But what I can do is take that first term and multiply by the denominator of that second term, which is x plus 2. And then I can multiply that second term by x over x. And you'll see where that magic happens. So here's what I did. I took that denominator of the second one and multiplied by it on the first one. And then I do want green. I took that first denominator and multiplied it on the second term. Now I can multiply across. 2 times x plus 2 over x plus 2 minus 3x over x times x plus 2. Look at that. Common denominator. I do actually think I'm going to distribute. So I have 2x plus 4 over x squared plus 2x minus 3x over x squared plus 2x. And I end up getting negative x plus 4 because, sorry, I feel like I'm going so fast. 2x minus 3x is negative x. And then there's just that little 4 guy who has to come along. And then the new denominator stays the same. So here we go. I'll give you a second. I know I went through that one really fast. There's just so many options. Well, um, there's, yeah, there are options, so many possibilities, but the goal is still the same. I want to have a common denominator, so I have to multiply by something to make that happen. And I cannot just multiply the bottom by something. I have to multiply by something over itself. And there you go. More information to come.